Good morning, everybody, for the third day of ZKProof 6 here in Berlin. We have a Greek session this morning, one after the other, right? And I'm very happy to have our keynote, Kostas, talk to us about ZK login and uses of zero-knowledge proof in practice. I don't know, Kostas, if you know, but I'm kind of a fan of what you guys did at SUI with ZK login, ZK send. Many people have seen me demo what they did, and they kind of think that maybe I had something to do with it, or our team. We don't. We just really like these deployments and these techniques, and I can't wait to hear what you have to present to us. Thank you very much.
All good. So very quickly, I've already mentioned a few things about myself in the past, like few days. I was personally used to be part of the Libra project at Facebook before I joined my current company now. Quite an experience on how you can launch a blockchain from a big organization that is very, very slow. And Web3 typically requires like a lot of speed. Many of the things that we did back then, even on the zero-knowledge proof space, like high-paid individuals and cryptographers there, couldn't be employed because to go up to the hierarchy until you reach mark, it takes quite a time, and then you're very slow on adoption. We worked a lot, even back then, we tried to solve the problems of having so many Instagram users where most of them cannot remember passwords. You will be surprised, but the majority of people, well, you know it already, cannot even have like a very basic password with enough entropy. So we decided to work back then, even focus as a whole company at Facebook, even before I leave, on how to solve this, right? Is there any way to actually get rid of the passwords themselves? Can we use a zero-knowledge proof in general to provide other means of authentication? And this is what I'm going to present now, which is very interesting, because ZK can be used in at least 10 places on how we're using it for logging into systems. First one, as you can see, is how we can make our signature algorithms to be more ZK-friendly. And this is required because we have situations like Zcash and other situations where the authentication is part of the full logic of verifying, for example, transaction on-chain. Even if it was off-chain, you still need the signature to be friendly. The second one is sometimes, especially as we go to the post-quantum world, some of the signatures that we're adding are very long or are very expensive. You need ZK to eventually compress them. Here, we don't care about most of the times, we don't care about the privacy property, but we care about the compression. The other one is there is a way, and I will show you how, to have conventional signature schemes and convert them into post-quantum schemes, even elliptic curve schemes. And you will see how it is possible even today. Then the work that I personally did and what Jonathan mentioned, it is even possible now to have login with Google, Facebook, whatever is the OAuth provider, and convert this through snarking into something that even Google doesn't know you're linking between your account at their company and the blockchain. And now you will see many companies. I'm working with many banks and like conventional entities. You will see that many of them are now thinking about passkeys. I believe it will be the next thing, even if I'm doing now ZK. All of the 20, 25 companies I spoke lately, they're working on passkeys. They believe that's the way to do it. People want to do biometrics. Maybe login with Google will be another like two-factor authenticator. But if you go to the main institutes, that's the main thing they're doing now. Coinbase, Wells Fargo, many companies are working on this. And then we can see how we can even convert the threshold MPC wallets to ZK wallets, because sometimes, you rely on like very complex cryptography. Many of them say, oh, I know how to do threshold EDDSA, threshold ECDSA. You're relying to their team to do it, and actually you are a link to their product. But there are ways to convert this into a ZK protocol without requiring the MPC. And there are other things that you will see. For example, we figured out that there are situations where you need attribute-based login. Literally, you have access to this account if you prove you're a citizen of Italy, you're having a particular driving license and something else, not your identity. You just have some attributes to prove in order to have access to some accounts. And there are situations where you know all of this concept of account abstraction. ZK can get the account abstraction off-chain. And it is even possible, even if you commit to a verification key, a verifying key on chain, to change the logic of the proving key, literally changing the circuit before you go into the smart contract. And this is very interesting. In my opinion, the only protocol that can do it now without leaking something and without make the system more complex is Jan's protocol, Growth 16, and I will explain why Growth 16 is not dead. This is a very important property. I was super surprised that there are situations where you don't need trusted ceremonies and you can update your contract. So very quickly, the first thing that we can do is zero-knowledge proof friendly signatures. Right? There are situations like the Ziggy from Starks, where in practice you want to create post-quantum signatures with some zero-knowledge proof property. And in this situation, it's very simple. Typically, the system, you are committing to a hash of your private key. And then whenever you want to sign a message, you're signing a message as an HMAC of the message, comma, the private key. And with zero-knowledge proof, you prove that the private key is matching between the hash and the HMAC. This is a very simple way to have zero-knowledge proofs in a post-quantum world with a post-quantum scheme. The other one is there are situations like Zcash and some other companies where they invested on getting the conventional algorithms like EDDSA and get the curve actually making it as zero-knowledge proof friendly as possible, and then you are having red jab, for example, here, or you might have another option with some other cryptographic scheme that you make it again like zero-knowledge proof friendly to be able to, I don't know, compress it or make the calculations faster and all of this stuff. Now, another situation is when we have many of these signatures now, and you need zero-knowledge proof, especially on high throughput blockchains, where you have to aggregate them. We all know about BLS. Yes, BLS is offering like good aggregation and so on. But now with zero knowledge, we're changing completely the narrative. Because in this situation, you can always say, oh, the aggregation can happen with some zero knowledge proof property. And this is what I explained before, how we can convert MPC wallets to zero knowledge proof wallet. What do we do now with ZenGo and all of these companies, right? We have a 2 out of 3 model. You have your key distributed in 3 different entities, and with some cryptography, like we can have a model where you don't see on Ethereum or on the other blockchain if this was a 2 out of 3, 3 out of 5, 1 out of 1, and all of this stuff. However, if we had an authenticator which is zero knowledge proof, you don't need MPC. You can just, as a user, and this is Growth 16 that actually makes some meaning here. You can just say, look, it's my account. I will personally create a ceremony for myself. And then I go to the other entities that keep like a share of my key. I give them the proving key. Nobody knows the proving key. The toxic waste is just for myself. I mean, I'm shooting myself in the foot if I reveal the toxic waste. And I give them a proving key, and this proving key is probably for aggregation of the signature, a 2 out of 3. So you give it to them, and then the blockchain only has a verifier, which is a zero knowledge proof verifier now. But nobody knows even your policy. I mean, if you make some adjustment even to the protocol of proving, you can even, the verifying key might not even reveal what the circuit is, because nobody knows the proving key, only you and the 3 entities that having the cert element, which is very interesting property to have now in crypto. Literally, ZenGo and other companies, I believe eventually they will go to ZK, because this one can offer you unlimited capabilities, even account abstraction now. You don't even need 2 out of 3. You might even say 2 out of 3, and if the public input is a transaction hash, you can unfold the transaction hash inside your circuit, and you can even say, and the transaction is less than $1,000, you need 3 out of 5. If it's more than $10,000, you need, I don't know, something else. So you can have now policies that it was not possible before with just very simple MPC wallets. I believe some startups will emerge here. I've never seen someone doing it yet. The other thing, OK, this is for Mutu. The other thing is PK fallback. Why PK fallback, right? What do we have now? We have EDDSA. We have people using mnemonics. From the mnemonic, eventually to go to the private key of elliptic curves. And then from the public key of elliptic curves and the private key of elliptic curves, you are signing with ECC some transactions. And that's how we accept, oh, the transaction was correct. But if you see, this is the EDDSA flow here. Almost all of the protocols now are requiring a hash element from your seed, from your secret, to the private key, and then to the public key. And then maybe all of the blockchains of the future can flip a button one day, and we say, from now on, we don't accept elliptic curve signatures. You just prove that you know the seed that goes to the private key of the elliptic curve. Forget the elliptic curve operations. And now we can convert Ethereum and all of the other blockchains into post-quantum ready. So post-quantum ready, I call it like, as we said with the TV screens, HD ready and all of this stuff. It is post-quantum ready, right? People who are following the protocol and they're using mnemonics, or they're using EDDSA, the seed that they have is not a private key element of the elliptic curve. It's a random nonce, and this nonce goes through some hashing. In this particular situation, do I have a laser? OK. This one. So you prove with zero knowledge that I know a seed, that from this seed, I can go to a private key of the elliptic curve. And now, with this, I'm using pretty much an algorithm, as I explained before, with Ziggy signatures. This is how I sign now transactions. Forget elliptic curve cryptography. Game over. It doesn't work anymore. But there is a benefit. You don't change your address. Your address remains the same. If you are an ESOP, you can still receive funds there. And even if elliptic curve cryptography is broken, you don't care anymore. But we need to flip a button. So the other one that I've seen very recently, is there are situations that previously we started, here is my password. And then we said, OK, now I will log in. Here is my driving license. No ZK yet. And then we go to more ZK-based authentication. This is my driving license, and I'm providing to you like a clue that I'm over 21, but you don't see my driving license. And then eventually you go to policy private ZK attribute. People don't even know what your policy is, which is super cool as a property, right? Imagine if nobody knows. I mean, account abstraction now on Ethereum, you have a smart contract where people can see how you're signing. What if we could hide completely the policy? And the policy can now be hidden with zero knowledge even before you go to the blockchain. Off-chain, everything can happen off-chain. And how a ZK authenticator would work on blockchains, pretty much what we have today. You verify a ECDSA signature or EDDSA signature, and from now on, you will say you verify a zero-knowledge proof. And this is very easy. Your address can be even the hash of the verification key, of the verifying key of the zero knowledge that you created. I mean, you can even run the ceremony in your head. Now you don't need other people to run the ceremony. It's your key. You can do your own thing. You can keep the toxic waste if you want. You can throw it away. You can do whatever you want. Nobody else is required to participate in the ceremony. This is the first application before designated verifier login where we can have Growth 16 without trusted ceremonies. There is a trusted ceremony, but it's coming in the head of the person who is interested about this stuff. So there are at least 2 applications now in the world that trusted ceremony is not required. And we can go a step further, which is what I explained, where the policy can also... Do you want to go back and take a picture, Jans? So the policy itself can even be hidden now. So you're having an extra advantage. And there is another thing that you can also do, which is super great. There is a way to change the prover of Jans to maintain the same verification key, but because you have the toxic waste, it's yours, right? It's your account. What you can do is you can play with some of the values during the proving like operation, where the verification key is oblivious to the policy, but you can even change it. I start with 3 out of 5, and down the road I say, delete it. I don't care about this. I will do 5 out of 10 without changing the verification key. And it is possible, and actually I'm not sure if any other protocol can do it at the moment, because the benefit of Growth 16 is 01, which means that even if you change the public inputs and everything, if you change the private inputs and some other logic internally, you don't necessarily need to change the verification key, right? You can still have the same key being able to verify multiple policies, not only the one that you initially created. All of the other protocols, unfortunately, are log-n or something else, which means that if you change the circuit, you have to change the verification key size. So you're leaking something. Then you have to go to other solutions. I will come to you, back to you, Jans, afterwards, because we're working on a paper on this, and maybe I need you here. So then, imagine I'm in the blockchain space almost forever, and I literally asked ChatGPT one day, what is the main problem? Why people are not using blockchains, and why people are, like, sometimes, especially like my wife, my parents, don't want to go easily into this sector. It's too many complex terms. On one side, sometimes I like Solana, and Anatoly, Tolly, because they simplify everything. They hide the fact that there is like Merkle trees, and they say compressed NFTs, and they say something else. And we cryptographers go and say zero knowledge proof, zap curves, and other stuff. And then the average person who sees that says, there is no way I can go and do blockchain. I don't understand anything. So we did a mistake, I believe, as a community, where we didn't simplify the terms. I've even seen people in their own proofs struggling with their colleagues about the notation. I use L, and you are using R, and someone else is using lambda, and it's a mess, right? Not even us can understand sometimes what's happening in our own papers. Which means imagine the average person what's there, right? It's more complicated even to go to regulators and convince them these things work, and like eventually it doesn't work. So this is another problem. Not everybody is an English speaker. Believe me, I did an experiment. Most people don't even know what is a garment. They don't even know what is a saddle. They don't even know a few of these things. If you provide them this as a password, it's more complex than providing them a string. They don't understand what these things are. So we have to go from passwords to something else, right? This cannot work. And imagine you have 12 or 24 of them. They don't know how to type it. And then one solution is, OK, however, most people, what do they have? They do have login with Google, Facebook, Apple, and all of this stuff. At least this exists. Somehow they have an account there. Can we use this, maybe snarking the response from Google and these companies, and convert them into something that not even Google can track your account on chain, or at least hiding your identity element on chain, but still have an address? So here what we did is this example. Now, this is a real, actually, output. When you press login with Google, this is what's happening in the background. You don't see it, but in practice, you are receiving a JSON file from Google. This is for every OS provider. At the header, you just see, OK, this is my key ID, and this is RSA. Like Google is signing the response back to you with some algorithm. And what is it signing? It's signing that there is, like, I'm the provider, Google, and then the audience there, imagine it's the app, it's the wallet, it's the website, it's anything. Then user ID is the element called sub. And there is a nonce there, because you want to protect against like replay attacks and all of this stuff, expiration times and all of this. Like very basic stuff. This is what it's returned back from Google. But if we put this on chain, that I'm this user with ID, blah, 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 obviously we're leaking something. We cannot put the JWT on chain. So another thing that this wouldn't help you, even if you put it there, you don't know how to sign transactions. The fact that you say, this is my identity, how do I sign a transaction? There was a problem until now, right? We didn't know how to use Google login to sign a transaction. But there was an interesting stuff here. Let's see. Let's make Google be a certificate authority without them knowing. So that was one of the biggest tricks. I mean, this is not actually my work. This was an original work that, like, together we came into the same conclusion, where, there is the nonce there. If there is a nonce, what I can probably do is I can put a public key there. So in practice, Google is signing, apart from the fact that I have my identity element, it's also signing a public key that I defined, and it links the public key with my identity. What it means now is Google is a certificate authority for myself. And there is also an expiration. It's literally a certificate. If you see this and you see another X509 certificate, it's pretty much the same. This is just JSON, and the other is XML. So the second trick is you can also have your email there if you want, but these three elements are the most important stuff. AUD, which is the website, sub, which is the identity of the user, and the public key. And a strawman address would be, OK, let's say on the blockchain, this is not the correct solution, right? This is a strawman until we go to the final solution. We have the hash of the provider ID, your wallet ID, and your user ID, this being your address on the blockchain. But this is leaking everything. If someone knows the provider is Google, wallet ID might be MetaMask or something else, and user ID, you can just enumerate all of the user IDs, and eventually you can link user IDs with users. This doesn't work. So eventually, let's see if we can add a salt there. Let's add some randomness to the address generation so we can hide the user ID. This is also something very interesting, because now at least you cannot go to the addresses on chain, and because you don't know the salt, you can play and identify user IDs of the users. Again, there is no zero knowledge proof here, strawman, solutions, and so on. And the salt can also be owned by the wallet, because the wallet just having the salt, it cannot get a JWT for you, and there is another element, they cannot add the public key on behalf of you, right? This is happening on the UX. So in theory, the salt is giving some power to de-anonymize on the wallet, but they cannot have access to your account, which is the important stuff. And then we go a step further. OK, even if this is OK, if this is like fine, because I want to snark it, I have to convert all of the hash functions into ZK hash functions, because otherwise it will be very expensive to prove this very fast. And I'm telling you the numbers now. There is no way we can have an authentication system that takes more than 5 seconds for the users. Most of the users will jump out. You need to find zero-knowledge proofs where this can happen in less than 5 seconds, and I would say less than 2 seconds. This is super important. And because authentication is typically happening independently from the users, you typically don't care about aggregations. All of the users will never collaborate between them like L2s. So in this situation, it's one of the zero-knowledge proof applications where everyone is acting independently. And this is super important because now you can pick what algorithms you can use, right? You don't care about some other properties. So then you snark it, and then you say, OK, I verify the JWT correctness. I verify that the signature of Google inside the JWT is correct. I do like many things about all of the sanity elements of the ZK. I verify knowledge of the pre-image, that the JWT user ID is part of it with my address. You remember there is an address where your user ID is there. So you are matching always, every single time you go on chain, that the address that I had, I go back. There is no public key here. Do you realize this? It's the first time that you have an address without a public key. Every single time you have to prove that you own a certificate, that the user ID is part of this certificate. And I can switch the public key, which means that if I go log in with Google, and then my network goes out, I can again go log in with Google. I have another ephemeral public key. It's fine. As long as I prove that I have a certificate that goes to this address, plus the salt that Google doesn't know it, it means that I can have access to my account now. And because of this, you don't need to remember any extra password. This is the important stuff. And the salt itself is not giving you power to get funds from the account. So that's how we did it. By the way, this is probably, let's see if I have, yeah, this is the whole story. And the validators, eventually, what do? When you're submitting a transaction, now you have a public key. You can sign the transaction, as you typically do, but this is an ephemeral public key. Every single time you can change it. It's an expired, continuously expired public key. Every one day you can get another login with Google. Every wallet can decide on their policy. I might say I need every hour. I might need for every transaction. I can do even this. But in any case, this is pretty much, and I say the address format is pretty much this. It's not exactly this, but for the sake of understanding, imagine that it's like these 4 elements. And the verifier now, the validators on the blockchain, they just verify a zero-knowledge proof. And now we have the link between the signature and the JWT, and can they verify a signature over a transaction. And now we have a full system that you can actually sign transactions. So this one is probably the most used zero-knowledge proof at the moment in the world, because we had some campaigns that there were millions of users per day using ZK login. Millions. I don't even Filecoin, I don't remember how many ZK, maybe someone knows here, they do per day. I think this is now the most used zero-knowledge proof product in the world, just because it's for every individual. That's why Jonathan probably mentioned you like the idea, because if you go and see all of the use of zero-knowledge, all of them together accumulatively do not surpass the use of ZK for ZK login. And we had some examples where even like big companies like Red Bull and others run campaigns, and everyone now has run a zero-knowledge proof in their life. It has happened. They know at least part of the game. Now, what is this circuit? We tried to do as many optimizations as we could to make it less than 1 million gates. This was very, very important. Imagine Go16 also has like a ceremony. You can avoid the ceremony if you want. You can have each user having their own, like as I explained before, trusted ceremony in their head. But we decided not to do it for now because it will be expensive on the browser. I hope Mutu will give me a solution one day on this. But in any case, like so many optimizations that like literally we spend a lot of time checking every single bit. We tried even this with RISC-0, that is a VM. 40 times more expensive. Hard-coded circuits are unfortunately by far faster than VM circuits. That's the reality. They're adding some extra complexity into the algorithm that unfortunately it makes the proofs very long and like expensive. So as you can see, the most operations are happening on the SAT2. Because we cannot go to Google and say, Google, the whole story was we don't want to change anything in the world because it's very difficult. Everybody has a solution in their mind, how we can do KYC, or we can do zero-knowledge proof with existing credentials. But typically, you need to go to them, and you say, oh, use zero-knowledge proof primitives, use these signatures, use the other things, and this will never happen. These companies are very slow. I'm coming from such a company, and I know this will never happen. It has to go through standardization. Without the standardization process that we had here, and unfortunately we go slowly, Jonathan, sorry for this, but that's the reality, it's impossible for a big organization, for a security manager who is almost a public sector employee at Facebook and Google to go and have a check mark if there is no standard, because you're losing your job if something happens. So at least you have evidence, oh, it's a standard, right? Look what I did. And that's why we have to move fast. The main reason of no adoption is two things, in my opinion. No standards, and no good IDs to write, Visual Studio and all of this stuff to write.
That hurts, oh my God.
Yeah?
What you just said hurts my feelings.
I know it hurts your feeling. I'm here from the very beginning, but I'm giving you some feedback, constructive. Yes. Anyway, we managed to do many tricks, even to compress RSA verification. Imagine, we need to verify the RSA signature internally. Why? In theory, we could verify it outside. Do you know the main reason why we did that? Can someone think about it? Google came back to me, I don't want to track the accounts. If I see the RSA signature and I know my public key of the RSA signature, I can track the account. So we needed to verify everything inside the JWT, including the signature from Google. So there was a way to hide the identity of the user for the public, but Google would still know. Now Google doesn't have the salt, and they cannot match addresses with JWTs, which is very important to give the salt to another entity, like the wallet or something. We also did a lot of optimization. String slicing, even string slicing, we had to go like as a surgery to make the string slicing faster. And even Poseidon hashing that we're using for the address now, it's only the address that we control. We cannot control the certificate from Google. There, we created at least a system that is zero-knowledge proof friendly. Anyway, that's the thing. And because at the moment we have the public key that is part of the JWT, you can, in theory, delegate the proof to a service if you cannot run it on browser. It is possible. I'm having accounts that I'm running them on my browser and my computer, but it's more expensive. So if you want to go 1 second, you can delegate it. The Rapid Snark can do it in almost 1 point something without very special machines. Some extra properties, I don't know if you can see them. It's very small. But the interesting part that we did is we made this native, not using a smart contract, which means that the wallets can directly use it. And because now we converted the MPC, I have 40 minutes, you told me, right?
Or you go ahead.
OK. Now it's not like a benefit of one particular company that says, this is the MPC wallet. If I don't exist tomorrow, maybe you can recover, but you don't have the system anymore, the 2 out of 3. Because this is a protocol, everyone can implement it. There is a big difference between creating protocols and creating products. And now we have many wallets that are actually doing very interesting stuff. Some people are using provers that are in SGX. Some others are offering like distributed salt like management and other things. Being native is also super cheap. I personally found a way to have 0 cost on all of the cryptography for all of the blockchains in the world. There is a way to do it. I mean, you have to think about how the big companies are doing it. The other thing is you can do geofencing. By the fact that we have even the email part of the JWT if you want, what you can do is you can prove afterwards with another zero-knowledge proof that there is an address there, that this address is at Brazil.something. So you know that this person is coming from there, even there is anonymity. You remove everything from the first part of the email. So for the first time, you even have addresses where you can do some like group management with like some properties in zero knowledge, and you can prove a few things like attributes for the address. And you can do another thing. You can even say, OK, this was created by some JWT, and maybe we can create other properties, because JWT has also things that we don't need them, like Facebook photos, I don't know, AIDS, and other things. where you can say, I can prove to you something inside the JWT, that the user ID is the one user that is creating this particular address, but I'm not giving you the user ID. So practically, we can do stuff that was not possible before at the address stage, which means that, oh, maybe gradually we're going to solve the KYC system as well, which is like another important property. It's not only onboarding. Believe me, onboarding, it's only the first thing. Now every Instagram user can just create an account like blindly. They don't care about passwords. And now you also have these extra properties. You can prove something about yourself. The other stuff is discoverability. Oh, you have a question?
Yeah.
Sorry.
Can't I create a Google account in any country just by using a VPN?
If you want to use it, right? That's what I'm saying. I mean, the person should accept the fact that I want to use it because you create the zero knowledge proof. If you don't want to do it, you don't do it.
Okay.
Right? That's the answer in practice. I understand that we want to add full privacy and other things, but in my opinion, because it's up to the user, it's only the user who knows this public keys and everything, nobody else can prove something for the user. Which is the interesting stuff, right? I mean, there will be countries where GDPR doesn't apply, or in this situation, it might be shop at Amazon.com. You don't care about revealing a few things about yourself. It's not only individuals. There are situations where these addresses should be public, and sometimes I'm paying Coinbase, and I'm shaking, is this a Coinbase account or it's something else? So there are situations where we might want to leak some of the privacy just because it's a corporate account, and these corporate accounts are public. You can even pay to an email now. What you can do is I'm sending you the salt, I'm texting the salt to Dara, and you can go, you have your account, and you can claim it. Nobody else knows apart from the two of us that it was you, but this address is unlinked to your other address with the other salt. I don't know your other addresses. And obviously, you can use this as 2FAs, right, which is very important as well. If the protocol allows multi-sig, or even with zero knowledge proof, you can, again, do aggregation. You can now have this or mnemonic in case you want to recover if Google goes away one day. Right? You can do multiple things here. So that's all pretty much. This is how it works in practice. Forget the fact that it's like a company now. Everybody can do it in theory. You just log in with Google, and voila, you have an account. And then you can send something. You put the destination address, blah blah, review. So now this is literally a zero knowledge proof on the background and all of the like back and forth. And now your transaction is on chain. It's interesting because it can also bypass some of the rules about custodian. Google is not a custodian. The wallet is not a custodian. And the user, in theory, has all of the power, especially if they use a 2FA here. So that's all for now. I hope you liked it. A few of the ideas, especially if we go at the very, very beginning, I want you to think about them, because most of these things haven't been implemented. Like there are at least three situations. For example, you have a puzzle base. Someone might solve a chess game and have access to this account with zero knowledge. Or you might have a trivia, pursue some game, and you have bots, AI, fighting with each other who will get access to this account. So we're creating new types of authentication. And I believe the new system will also get the account abstraction into a privacy layer before the blockchain. It's like an L2 only for like your Lightning personal network, only for authentication. So it's a new paradigm completely. Thanks, everybody. That's all from my side.
OK. Who has questions other than myself? Because I have at least 3. All right.
The circuit repository you linked doesn't seem to be public.
What was that again? Sorry?
You linked the GitHub for the circuit, the Circum circuit. It's
the
not,
Circum circuit, yes?
Yeah, it's not a public repo. It's not there.
Oh, you can't access it?
Oh, the circuit, by the way, the GitHub itself is public. I know, but it is. I mean, all the people who participated in the ceremony, they had it. But you know, there is some competition there with other blockchains trying to clone us, and we can always provide it if someone wants the circuit,
oh, so
and you can verify it.
Almost public.
It was public until we realized the same thing that happened to ZKs, that a lot of people are cloning our job.
Got it.
And this is not good, in my opinion. Like so fast, even before you even use it.
Is it good? Is it not good?
Our code is MIT Apache, so
I know, but
anyone can clone it. That's OK by me.
True. You remember Halo 2 and what happened with Mina, right? This debate that they used.
Yeah, we encouraged them to use pasta.
Yeah, but at the very beginning, they didn't tell you that they are using it, that they launched faster than you.
They did tell us.
Huh? They did tell you? Yes, this is what we do as well, eventually. So
okay, I'm fine with it. I want this technology to be promulgated.
Makes sense.
Yeah.
By the way, I was personally, because of the public comments, I was personally affected by the case that you had with the other blockchain. Because in the network, we could see there was a debate. And then I said, oh, they did something. I don't know how much time did it get them to go there, and someone is going first out without them being the first blockchain to use it. At least that was the perception, unfortunately, on the public.
I wish actually we'd been more open and we'd licensed, for example, the Orchard repo as MIT Apache from the start. That's what I advocated for.
Thank you.
I must say, at Kedit, right after we audited the Zcash work, we knew that it was great to use on enterprise projects, so we did exactly that. And we reused the code base. Anyone else? Did you guys get the part about the trusted ceremony of self and those modifications? I'm actually interested in just understanding a bit more. How do you solve for the fact that if I have the toxic waste, I can convince anything to anyone on the other side? So I just missed that piece.
By the way, we're preparing a paper about this. There is a flow in Jan's protocol where you can, if you have the toxic waste, you can change the parameters there and literally commit to a different, we did it, we implemented it, in a different circuit now. So it is technically possible. You only change the prover, by the way, not the verifier. The verifier stays the same. You can understand how it works, I guess, in your brain, right? But we can talk as well. But it is possible.
Okay.
Actually, if you have the toxic waste, you can even completely bypass all of the expensive operations of the proof if you want, right? Sometimes, this was also a requirement. There are people who have the toxic waste in the vault. This is in the bank. And if something happens, and for some reason you cannot prove with zero knowledge proof because something happens, at least you go there, and with the toxic waste, you bypass all of the circuit process. I'm not kidding, but I've seen it happening in a custodian.
Maybe it's time to not call it toxic waste then.
Yeah. But you don't need to do all of these seconds and all of this.
Let's call it circuit breaker.
It's a circuit breaker, yes. But the other thing that you can do, you can create another circuit on top of, completely get rid of the previous one and have another circuit now. And then you put this new circuit in the vault, and from now on, you forget the previous one.
More questions? All right. One small thing, the JWT that comes back from Google,
yeah.
It looks like there's a bunch of spaces there. Is that intentional?
What is there?
This thing.
Oh, no, I hide it. The sub. I don't want the sub to be public. Right?
Oh, you're being private about the identity of this dude.
This is literally on the Google Slides a white text box on top of the sub. Yeah. Yeah.
Right.
So typically there are no spaces.
Hey, thank you. Just a quick clarifying question. I was confused. Are you using the nonce as a public key, or you're putting in a new public key in place of the nonce?
The hash of the public key is the nonce, and some extra expiration date that you want to add. You're concatenating them, and you put it as a nonce into the JWT, and you send it to Google.
How are you able to just... Oh, you send that to Google?
The hash of the public key, you send it to Google.
Oh, the user gets to pick the nonce.
The
user gets to pick the nonce.
Yes.
I see. OK, thank you.
So on your UI, look, every wallet you trust the UI. There is no wallet that you don't trust the UI in the world. That's the reality. So there, what you do is, on the UI, you're generating an ephemeral key. You're creating a nonce, and you send this to Google.
Yeah, you have to trust the UI, because if it tells you you're sending here and not here.
Exactly. This thing, we didn't solve it yet, right? Maybe in the future we might come up with something that there is no UI. But at the moment, there is no wallet that you don't trust the UI. Even hardware wallets, right? If they show you something else, you just accept it.
OK. Thank you very much.
Thank you.